Okay, excellent. So this came out a few days ago, 11th of June. I like it a lot. It's a long paper. I admit I haven't read it all just yet. I went through the first 10 pages. What I like about this paper, by the way, comes from Todai, from Tokyo University and NTT in Japan. They look at measurement-based quantum computing, which is the framework we mentioned a few episodes ago, which is great already because I'm a big fan, as I said. But even better, they do something that I really admire when people take the time to actually break down a comprehensive piece of work and look at all the different ingredients. So let me scroll down. I have emphasized a few things so it's easier for people to check. So we spoke about MBQC last time. Is a different way to think about quantum computing. Rather than looking at the gates and the circuit, you do the same, is equivalent, but you do so via measurements on a resource state. The main claim of this paper is that they construct what they say a low overhead protocol to implement fault-tolerant quantum computation using MBQC on a photonic framework. So this is the main claim. And without getting too much into the details, what I really would like to emphasize, and I'm scrolling down, is that they do a great job, and this is really for the interested listeners or researchers out there. They do a great job in guiding the reader through all the gory details of the scheme, which is great. This is exactly what you want. And they also tell you what to skip if you just want to look at the specific polylog overhead MBQC that they came up with. So if you love MBQC, if you want to get a good sense of how error correction and fault tolerance might look on near-term / future devices, this is a fantastic paper for that. And I'll stop sharing unless you have any question.
I think
André?
papers like these are important to also make it tangible. What are the next steps to do error correction and to make it practical and to go from proportionality science, this is how it will eventually look like, to saying, look, this is the first thing you try, this is how you actually do it. I mean, I remember when the surface code came out, that was crucial to demystify the surface code by this. There's the famous 60+ page Fowler et al. Paper that did a fantastic job on that. And that, I think in a seminar, it takes about 4 hours to present the main ideas, not the whole paper.
Wow. But you're absolutely right. Your comment is really spot on. I love it when people are starting to think quite actively and also very pragmatically about how error correction might look like in the next 5-10 years. It's great. It's really great. It's moving the whole field forward.